Assalamualaikum. I am Khalida binti Muhammad Noor. My matrix number 231-333-499. I am from Group 5. For today, my group and I will be presenting our mini project 2. It is mostly about bridge. The location of the selected bridge is located at Aeropolis. First, the topography shows that this site generally is flat and it is the rural network. This area is mainly used by pedestrian and light vehicles, making it suitable for bridge construction with minimal earthwork. Second, the geotechnical profile indicates that the soil consists of soft alluvial deposit. This creates a high risk of ground settlement and low bearing capacity. Therefore, a deep foundation system such as driven pipe is recommended to ensure structural stability. Lastly, the hydrological profile shows that the watercourse is slow-moving and contains turbid water during the rainy season. Increased water flow and vegetation buildup can cause erosion and scouring around the bridge piers and abutments. Because of this, proper scour protection and regular maintenance are essential to maintain the bridge's long-term safety and performance. Based on our analysis, the bridge is classified as a local access short-span bridge, mainly serving local traffic and pedestrian. The bridge is constructed using reinforced concrete for both the superstructure and substructure. It adopts a cast-in situ construction method which provides good durability and structural integrity. The structural system is a simply supported beam where the deck transfers the load to the horizontal concrete beams, then to the column, and finally to the foundation. This beam configuration minimizes structural complexity while maintaining adequate strength and stability. In addition, reinforced concrete offers excellent resistance to water exposure, making it suitable for the low-lying alluvial environment.
Assalamualaikum. My name is Udamatun Nuradia. Matrix number is 231332181. Okay, to effectively manage bridge infrastructure, we must first understand its structural anatomy. Okay, as shown, a bridge consists of two primary systems. The first one is the superstructure and the second one is the substructure. The superstructure includes the deck slab, main beam, or grinders and bearings, which function to directly support and distribute traffic loads. Okay, beneath this, there's the superstructure, consists of the piers, abutments, and foundation, which works together to convey these accumulated loads safely into the ground. Okay, next we move to the construction phase. Okay, the slide outlines the systematic cast in situ construction methodology, which follows a disciplined 7-step sequence from initial site preparation and foundation works through to final finishing works. This process relies on a specific equipment matrix as detailed in the slide. Okay, formwork is utilized to shape the structural elements, mixers and vibrators, ensure concrete compaction and uniform density. Cranes are essential for positioning, reinforcement, and lifting heavy material, and scaffolding is used to support workers while maintaining structural alignment. Finally, long-term structural integrity is maintained through rigorous diagnostic protocols. As shown in the slide, all condition ratings and subsequent rehabilitation plans are strictly aligned with H2 bridge evaluation guidelines and JKR standard specification. We evaluate the health of the structure using condition state CS scale, which range from CS1, indicating no structural reduction, up to CS4, which denotes severe damage that warrants an immediate structural review. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amar Shifrin bin Ghazali and I will continue the presentation. For diagnostic panel 1, metal railings and features. For the railings, the inspection show a condition state 3, which means poor. We found severe corrosions, section loss and anchor bolts detaching from the concrete parapet. Although this does not yet affect the bridge load capacity, it compromises pedestrian safety and barriers. For diagnostic panel 2, deck and wearing surface, the deck and wearing surface are in condition state 4, which is severe. There are advanced cracks, potholes, and water ponding. This surface is not considered no longer effective. Surface is considered no longer effective, and constant water infiltration is accelerating damage to the reinforced concrete deck. This requires immediate structural review. For diagnostic panel 3, concrete substructure and beams. For the beams, we observe condition state 2, fair, with moderate efflorescence but no rust yet. However, the abutments are in condition state 4, severe, with spalling beyond acceptable limits. Vegetation growth at joints is worsening moisture retention, so this part also requires structural review. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Mukesh Ahmad bin Mantrun. My metric number is 2313324. So, I will continue with maintenance and rehabilitation tips. Component 330 the observed defect is corrosion and detachment. The HTO rating is CS3. Intervention type is corrective replace. Describe action clean rust, repaint, replace broken bones. For component 510 very surface, the observed defect is potholes bonding. HTO is CS4. Intervention type is corrective rehab. Describer action is patch potholes, reseal cracks, and asphalt overlay. For component 110 and 215 concrete elements, the observed defect is fluorescence spelling. The HTO is CS2 for intervention type is preventive protect. Describer action is clean deposits, high waterproof coating, and test spelling. Final verdict, serviceable with required intervention. The Arau RC bridge currently maintains structural serviceability, but critical intervention are required to mitigate active CS4 deterioration and on the deck and abutments. First, implement routine maintenance. Implement an inspection and cleaning cycle every 3 to 6 months. Focus on vegetation removal and drainage clearance. Number 2, preventive protection. Immediately deploy waterproof coatings, epoxy crack sealing, and anti-corrosion painting to slow elemental degradation. Number 3 is corrective rehabilitation. Execute structural patching for concrete spalling and entirely resurface and compromise spot deck to eliminate water flow. For us, thank you.